Good morning. This is Melissa J. Silva, your mathematics teacher for the school year 2020-2021. To our parents, the module you receive is made for the child to learn the needed skills in mathematics. This is composed of discussions and activities where your child can learn, and as a guardian, you have a great role in helping your child to learn while at home. Your guidance is needed so that he or she can understand the lesson and instruction better. Thank you for always showing your love by continuously helping them. And to my dear students, welcome to grade 9 mathematics. Let us have our first lesson, illustration of quadratic equation. Our objective, illustrate quadratic equation and identify the degrees of polynomial. Okay. Our first activity, do you remember this product? Direction. Find each indicate product, then answer the questions that follows. Okay, what is a quadratic equation? A quadratic equation in one variable is a mathematical sentence of degree 2 that can be written in the following standard form. Ax squared plus bx plus c is equals to 0, where a, b, and c are real numbers, and a is not equal to 0. In the equation, ax squared is called quadratic term, bx is called the linear term, and c is called the constant term. Okay, so let us have our first example. Okay, 2x squared plus 5x minus 3 is equals to 0 is a quadratic equation in standard form, with a is equals to 2, b is equals to 5, and c is equals to negative 3. Our second example, 3x times the quantity x minus 2 is equals to 10 is a quadratic equation. However, this is not written in standard form. To write the equation in standard form, expand the product and make one side of the equation 0 as shown on our solution below. 3x times x is equals to 3x squared. 3x times negative 2 is a negative 6x is equals to 10. Making one side of the equation 0 by adding a negative 10 both sides, resulting to 3x squared minus 6x minus 10. Therefore, the values of a is equals to 3, b is equals to negative 6, and c is equals to negative 10. Let us have example number 3. The equation, the quantity 2x plus 5 times the quantity x minus 1 is equals to 6 is also a quadratic equation, but not written in standard form. Just like in example 2, the equation, the quantity 2x plus 5 times the quantity x minus 1 is equals to negative 6 can be written in standard form by expanding the product and making one side of the equation 0 as shown on the next slide. Okay, so we have here the quantity 2x plus 5 times the quantity x minus 1. So we have to use the FOIL method. So 2x times x is 2x squared. 2x times negative 1 is a negative 2x. 5 times x is 5x. 5 times negative 1 is a negative 5 is equals to, then copy negative 6. Combining like terms resulting to 2x squared plus 3x minus 5 is equals to negative 6. Making one side of the equation 0 by adding positive 6 both sides, resulting to 2x squared plus 3x plus 1 is equals to 0, making our a is equals to 2, b is equals to 3, and c is equals to 1. One way to write our equation is when b is 0, in the equation ax squared plus bx plus c is equals to 0, it results to a quadratic equation in the form ax squared plus c is equals to 0. Examples. Equations such as x squared plus 5 is equals to 0. Negative 2x squared plus 7 is equals to 0. 16x squared minus 9 is equals to 0 are quadratic equation in the form ax squared plus c is equals to 0, where the value of b is equal to 0. Okay, Okay, so let me have this one. If you have more questions, you can watch the video or you can text, call, or message me, okay, to help you answering your activity. Okay, so let us have activity 2. Quadratic or not quadratic. Direction. Identify which of the following equations are quadratic and which are not. If the equation is not a quadratic, explain. Identify the degree of the polynomials. Let us have our activity 3. Set me to your standard. Direction. Write each quadratic equation in standard form ax squared plus bx plus c is equals to 0. Then identify the values of a, b, and c. Then answer the questions that follow. To continue, okay, so reflections. Activity 4. Dig deeper. Directions. Answer the following question properly. Okay, so I think we're done with session 1 of our lesson. So thank you and have a nice day. And we're going to have our session 2. Thank you. See you. Welcome to session 2 of our lesson. Okay, this is again Mrs. Melissa J. Silva, your mathematics teacher. Okay, so our lesson for today is solving quadratic equation by extracting the square root, factoring, completing the square, and using the quadratic formula. Okay, this is all solving quadratic equation. Okay, our objectives: use the different method in finding the solutions of quadratic equation by extracting the square root, factoring, completing the square, and using quadratic formula. It will also determine what method is appropriate to use in solving quadratic equation. Okay, let's start with activity 1. Find my roots. Okay, the direction. Find the following square root. Write the question. Rather answer the questions that follow. Okay, so let us have. We're done finding the roots. So we have here what made me. Okay, factor each of the following polynomials and answer the questions that follows after this activity. So let us have. Let us analyze the given equations. Okay, so let us analyze that. So here we go. Equation A, B, and C are expressed in perfect square trinomial. The factors of the perfect square trinomial is a square of the binomial. Okay, so let us have letter A. So x squared plus 4x plus 4. Okay, so let us factor that. Open and close parentheses. Make two open and close parentheses. Factor the first term, x and x. Factor the last term, 4. The factors are 2 and 2. And cut the sign of the middle term, which is positive. Positive and positive. Okay, so as you can see, we already have the factors. Okay, since they are equal, we can write that as a square of a binomial, just like this one. Okay, do you get it? So let us have example number 2. Example B. X squared minus 6x plus 64. Okay, make an open and close parenthesis. Factor the first term, x and x. Factor the last term, 8 and 8. Copy the side of the middle term. Okay, there you go. We have the factors. Let us express as a square of a binomial. Okay, there you go. Okay, example C. x squared plus 2x, I, sorry, x squared plus 2 over 3x plus 1 over 9. Okay, we can open and close parentheses, factor the first term, factor the last term, which is 1/3, copy the sign of the middle term. There you go. Express as a square of a binomial. Okay, it's so easy. There you go. Okay, so another thing, to find the third term of a perfect square trinomial by completing the square, or the completing the square must be applied. Okay, for example number 1. So we have the same example. So on the first example, since we have to find the third term here is 4. Okay, to make this one a perfect square trinomial. Okay, so let us have, where did they get 4? Okay, so divide the coefficient of x, which is 4, by 2, which is constant. 4 divided by 2 is 2, then squared is equal to 4. There you go. Next example. Okay, the coefficient of x is negative 16. Divide by 2. The result is negative 8. The square of negative 8 is 64. There is 64. You get it? Okay, another one. 1/2 of 2/3. Okay, when you are multiplying or dividing fractions, okay, you have to get the reciprocal of the denominator. The denominator is 2, then get the reciprocal of 2, which is 1/2, multiply to 2/3, the will result to 2 over 6, or 1/3. Then square of 1/3 is 1 over. There you go. It's like magic. So can you do this activity 3? Make it perfect. Okay. So direction, determine a number that must be added to make the following a perfect square trinomial. Explain how you arrive at your answer. Then answer this question. Okay. So let us have activity 4. Our activity 4 is it's good to be simple. Mm. Simplify the following expression and answer the questions that follow. Okay, just follow the given expression. And you're going to write in an answer. Okay, then answer this question. Okay, there you go. Okay, so what I know. Okay, let's recall. Okay, a while ago we have already know that the standard form of the quadratic equation is in the form ax squared plus bx plus c is equals to 0, where a is not equal to 0. This is also can be written in as ax squared plus bx is equals to 0, where the value of c is 0. And also ax squared plus c is equals to 0, where the value of b is equals to 0. Okay, this is it. Okay, what is in? Okay, since we're going to tackle 4 ways of solving the solution of a quadratic equation, here we go. First, extracting the square root. Okay, just listen, how are we going to use the square root or extracting the square root? Okay, a quadratic equation A quadratic equation, when written in the form x squared is equals to 7, can be solved by applying the square root property. If k is greater than 0, then x squared is equals to k has a real solution, or 2 real roots. x is equals to positive and negative the square root of k. Okay, there you go. Second, if k is greater than 0, therefore, x squared is equals to k has only one solution or one root. X is equals to 0. If k is less than 0, then x squared is equals to k. Has no real roots or solution. Okay, so let us have this example. Find the solution of the equation x squared minus 16 is equals to 0 by extracting the square root. So we have here x squared minus 16 is equals to 0. Write the equation in the form x squared minus k. So x squared is equals to 60. K is equals to 60. Then apply the square root of both sides. The result is x is equals to positive and negative 4. X sub 1 is 4, x sub 2 is negative 4. How many solutions do we have? X sub 1, x sub 2, therefore two solutions are good. Yeah. Okay, so let us have example number 2. Okay, so k squared is equals to 0. Since the equation has only one solution, because when you apply the square root property, the result is k is equals to 0. When k is equals to 0, or x is equals to 0, it has only one root or solution. Okay, example number 3. X squared plus 9 is equals to 0. In the form x squared is equals to k, then apply the square root property on both sides. There you go. X is equals to negative. The square root of negative 9. Some students will answer this one as positive and negative because they don't mind negative sign on 9. Okay, remember this. Note, perfect square cannot be negative. Therefore, this is not a perfect square. Therefore, it has no real roots or solution. Okay, let us continue. Activity number 5. Extract me. Find the solution of the following quadratic equation by extracting the square root. Then answer the questions right after that. There you go. Okay, so let us continue. We're done with extracting the square root. We're going to proceed on factoring. Okay, so how to use factoring, or how are we going to solve the solutions using factoring? Okay, so a while ago we factored quadratic equation. So let us have this one. Find the solution, transform it into standard form. There you go. Ax squared plus bx plus c is equals to 0. Okay, then make an open and close parenthesis. Okay, factor the first term, x, and x. Factor the last term that will result when you add to your middle term. 8 times 1 is 8. But when you add 8 and 1, it's 9. 2 and 4 are also factor of 8. We cannot use that because when you add 4 and 2, the result is 6. Okay, therefore we're going to use the factor 8 and 1. Okay, so resulting to x plus 1 is equals to 0. To extract our solution, x sub 1 is equals to negative 1, and x sub 2 is equals to 2. We have two real solutions for okay, so you can check if your answer or solutions are correct by substituting your value. Okay, so let us have another example. Okay, 9x squared minus 4 is equals to 0. Open and close parenthesis. Factor the first term, 3x and 3x. Factor the last term, 2 and 2. Since negative 4, since this one is negative 4, when you factor it, 1 is positive, there is a positive, and 1 is a negative 1. That will result to negative 4 when you multiply it. Okay, then set the factor equal to 0. 3x minus 2, 3x minus negative 2. Therefore, our x sub 1 is 2 over 3, and x sub 2 is negative 2 over 3. There are two real solutions of roots. You get it? Okay, so let's continue. Okay, factor then solve. Solve the following quadratic equation by factoring. Answer the questions that follows. Here you go. Okay, we are on our third way of solving the solution of quadratic equation. This is by computing the square. This method involves transforming the quadratic equation into the form the quantity x minus h squared is equals to k. To solve the quadratic equation by computing the square, there are some procedures to be followed. Followed. Okay, you follow that. Okay, example. Here we go. 3x. No, sorry. Find the solution of x squared minus 6x minus 41 is equals to 0. Okay, so first step. Add 64. No, sorry. Add 41 in both sides of the equations. Okay, so this will result to adding positive 41 here and adding positive 41 here will result to x squared minus 6x is equals to 41. Okay, there you go. So where did positive 9 here and here came from? Oh, okay, here we go. To get that 9 here and 9 here, we have to square of 1/2. 1/2 of the middle term, which is negative 6 times 1/2 is equals to negative 3. That will result to negative 3 squared. Negative 3 times negative 3 is 9. There you go. You add 9 here, also 9 here. That's completed. Okay, not yet done. Okay, so we have our next step. Okay, since we make our equation here a perfect square trinomial, okay, therefore the factors are x minus 3 and x minus 3 is equals to 50, making this one a square of a binomial. Okay, factors, okay, expressed into square of binomials. Okay, then you apply square root property. Okay, that will result to x minus 3 is equals to positive and negative the square root of 25 times the square root of 2. Then x sub 1 is equals to 3 plus 5 the square root of 2. X sub 2 is 3 minus negative 5 the square root of 2. We have two real solutions of this. Okay? So there you go. Activity 7. Completing. Direction. Find the solution of each of the following quadratic equation by completing the square, then answer the questions that follow. Okay, there is the question. Okay, so we're proceeding on our next idea using the quadratic formula. You know, this quadratic formula is derived from the method of computing the square. So, deriving ax squared plus bx plus c is equals to 0 will result to this formula. this formula will be used to find the solution of our example here. Okay, so let us have, okay, how to solve that. Okay, so 2x squared plus 3x is equals to 7. Okay, determine the values of a, b, and c. There you go. Make the equation in standard form. Identify the values of a, b, and c. Then, here is the formula. Do not forget, negative b is constant plus minus the square root of b squared minus 4ac all over 2. Substitute the value. There you go. Ayan. Okay, sorry. Okay, so there we go. X is equals to negative 3 plus minus the square root of 3 squared minus 4 times 2 times 2. That will result to a negative 3 plus and minus the square root of 9 plus 216. Okay, so 9 plus 216 is 225. 225 is a perfect square, which is square root of 225 is 15. There you go. We have our x sub 1 and x sub 2. We just separate the positive and the negative here. So negative 3 plus 15 all over 4. We have negative 3 minus 15 all over 4. Okay. X sub 1 is 12 minus divide by 4 is 3. X sub 2 is negative 18 over 4 is equals to negative 9 over 2. Okay, there you go. Okay. So after that, you do this activity. Activity 8 is the formula effective. Okay, direction. Find the solution of each of the following quadratic using that formula we have discussed. Answer the questions that follows. Okay, so since we are done with activity 8, we have activity 9. Solve the following equation by, so we're going to do it by extracting the square root, factoring, completing the square, and the quadratic formula. Okay, so let us have that one. Okay, so what I have learned, okay, write the step-by-step procedure in solving quadratic equation. 1. Extracting the square root. 2. Factoring. 3. Completing the square. And 4. Using quadratic formula. Okay? So last activity. Activity 10. Make the most out of direction. Answer the following questions. Okay? Write down your solution. Okay, for the last one, this is only for your reflection. Okay, right? I realized that, so on and so forth. Then I learned that, so on and so forth. Okay, so if you have any questions, you can call, text, or message me so that I can help you. Okay, so for that, I think our session 2 ends. Okay, so hope to see you in the next lesson. Okay, so thank you and have a nice day. See you.